yung mga kakapitan nyo or tatanungin kung nahihirapan kayo. So you can approach your classmates for a group study, or you can also approach me during consultation hours or during class kung meron talaga kayong mga questions, okay? So I think the recording started. So again, good afternoon, everyone. So today we'll continue our talk about limits, okay, limits of sequences in particular. So last week we talked about sequences being functions whose domain is the set of natural numbers. Intuitively, sequences are just an infinite list of real numbers, though the range or the list of possible values in the list might be just a finite set, okay? And then, and pan sabi natin, oh, it's not just a list, but it is an ordered list. So the ordering of the elements matter because the business of analysis is to look at what happens at the tail end of the list. So gusto nating tingnan ano yung nangyayari dun sa dulo ng listahan or when the subscript increases, okay? Now, we proved several nice results about the limit of a sequence. Of course, we said na not all sequences have a limit. So hindi sila lahat may limit o hindi lahat sila nagko-converge. But if the limit exists or if the limit of a sequence exists, then it must be unique. Hindi pwedeng magkaroon ka ng limit na dalawa yung, magkaroon ng sequence na dalawa yung limit. Kasi isa nga lang yung limit whenever it exists. And then another nice result is that every convergent sequence is bounded. So kapag ka alam mo na yung sequence na binigay sa'yo ay bounded, automatic, then it is bounded, right? And when we say bounded, there is a fixed constant real number m that is larger than everything or is larger than the absolute value of everything in the sequence. Okay, so dapat mas malaki siya sa absolute value ng lahat ng elements or terms ng sequence for the sequence to be bounded. Okay. So actually, Theorem 2.2 is usually also interpreted as a divergence criterion. Remember from Math 101, kapag ka meron kang statement na P implying Q, so meron kang conditional statement P implying Q, so we say that this is equivalent to not Q implying not P. Ano nga yung rule na to? Tatandaan niyo ba yung tawag dito? Padali, plus points. So anong tawag nga sa rule na to? Hindi niyo tanda, kinalimutan niyo na. Oh, this is called the contraposition or simply transposition. And this is a rule of equivalence. So yung P implying Q, ang contraposition niya ay not Q implying not P, which is also true, right? So kung true yung P implying Q, dapat true rin yung not Q implying not P. And actually, it intuitively makes sense. Kasi kapag ka si P ay totoo, automatic magpa-follow si Q. Pero kung alam mo si Q ay hindi nangyari, so hindi dapat mangyari si P. Kasi kung nangyari si P, automatic na magpa-follow si Q. Pero hindi nga nangyari si Q. So dapat hindi mangyari si P. So the denial of the original consequent implies the denial of the original antecedent. So equivalent sila. So if we will apply this rule or the contraposition to Theorem 2.2, what do you think will be the new statement or the equivalent theorem? So pwedeng ito yung version 2 ng Theorem 2.2. Anyone? Tawain ko siyang version 2 in quotes, pero equivalent lang naman siya dun sa Theorem 2.2. So anybody who wants to try, ano yung contraposition ng Theorem 2.2? Because you might find it more helpful or more useful in succeeding exercises. Oh, yes, Dan Kennedy, go.
Sir, ano po, if the sequence is not bounded, then the limit does not exist.
Okay, perfect. Thank you, Dan. Yeah, that's right. So if a sequence AN is unbounded, then its limit doesn't exist. Or you can just say it is divergent, right? It is divergent, right? So why do I say this is more useful than the original statement of Theorem 2.2? Because again, our business in analysis is to analyze if a sequence is convergent or not. If we'll be able to show that it is convergent, it might be also of interest to look at what is its limit. So laging puzzle sa atin kung convergent ba siya or hindi. Pero if you look at the phrasing of Theorem 2.2 as originally stated, lahat ng convergent ay bounded. Convergence implies boundedness. Pero ang problema nga natin sa analysis, hindi tayo sure kung ang sequences ay convergent. It is usually often a big mystery, okay? So that's why siguro hindi ganon ka useful ang Theorem 2.2 on its own. But if you take its contraposition, which as Dan mentioned, kapag ka siya ay unbounded, ibig sabihin siya ay divergent automatically. So it is sufficient to check the boundedness of a sequence. If it is not bounded, then automatically it is divergent. Okay? Pero ang problema natin kung siya ay bounded, hindi necessary na siya ay convergent na. I guess one of you guys gave me an example last time ng isang bounded sequence pero hindi siya convergent. So which is a proof that the converse of Theorem 2.2 is not true. Kaya hindi pwedeng if and only if yung 2.2. So, hindi lahat ng bounded ay convergent. So later, we will look at ano yung kailangan kong idagdag sa pagiging bounded para maging convergent yung sequence. Alright? Kasi yun nga, hindi totoo yung converse. Pag bounded, hindi necessary convergent. Pero may posible kaya tayong idagdag na property aside from boundedness para mapakita na siya ay convergent. So we will look at that later just to make Theorem 2.2 more helpful. But at least we got a divergence criterion coming from Theorem 2.2. If it is unbounded, automatically it's divergent. Okay? So we look at the proof of this statements last time. And I guess now we're ready to work with some limit theorems. Or before that, you have some exercises here, so you can try them up. Let me see kung may mahirap pa dito. Yeah, I think you can try this exercises. Let me know if you got some trouble looking at them. Tapos isa pang magandang way ng pag-aaral, if na-try nyo na siyang i-prove, na-stuck kayo somewhere, or hindi nyo na talaga alam yung gagawin, so pwede kayong mag-search sa internet. I do not discourage students from checking the internet. So merong mathexchange.com, merong mga wiki proofs. So you can take at how they prove the theorem, okay? Tapos pwede nyo siyang i-adapt and then try to paraphrase it, justify every line, okay? Isipin nyo bakit nasulat tong line na to? Or ano yung kailangan kong idagdag dun sa proof to satisfy para maisama ko lahat ng detalye, all right? Because in your work, I am expecting to see all the details, all right? So kasi ina-assume ko na hindi ako yung magaling mag-reason out on my head. So hindi ko kaya yung maraming nilalampasan. So kung mapapansin niyo sa proof, talagang step by step. Kasi hindi ko kaya yung from step 1 pumunta sa step 4. Ang kaya ko lang is step 1 to step 2, then step 2 to step 3, saka pa ako pupunta sa step 4. So kaya siguro sa mga homeworks, lagi kong hinahanap yung same level of rigor. So make sure that you present your proof in your own words and then with all the details that are necessary for a layman to understand, or not just a layman, but one of your classmates to understand the proof. So yun yung tinitingnan ko sa mga homeworks, okay? Now, oh, by the way, before I go to 2.2, another reminder, homework number 3 is due on Monday, right before midnight. Kailangan niyo pa ba ng extension doon? I guess madigay lang naman siya. So bigay lang kayo ng isang sequence, then ipoprove niya by definition. So I imagine it's fine to leave the deadline on Monday. Kasi ayoko na siyang i-move kasi sa week din na yon meron tayong problem set. Tama nga ba? Yeah, next week na yung problem set. So ayoko na siyang i-move na mag-overlap dun sa problem set para you get it away. And problem set na lang ang intindihin nyo midweek next week. So, okay lang ba yun? Nakita niyo na ba yung homework 3? Wala namang request to extend? Kasi hindi ko siya, kung ako lang magde-decide, hindi ko na siya extend. But if you think you need an extension, then you can request for one. Pero, okay lang ba yun? Walang requests? Okay, I take your silence as a no. So, all right. So with that out of the way, let's go to limit theorems. So limit theorems will try to revisit this theorems that you already know from your calculus courses, from your Math 36 until 38. So ito yung mga ginagamit nating limit theorems. So just revisit them and see, and actually pinrove nyo nga rin yata yung iba rito eh. So let's just review the proofs and see what are their technical nitty-gritties, all right? So the first bunch of theorems are called algebraic limit theorems because it will tell us the relation between the limit of two sequences and the limit of a sequence form by performing algebraic operations on the terms of the respective series, right? So for instance, ang assumption natin dito sa theorem 2.3 is that we have a sequence of ANs that converges to A and the sequence of BNs that converge to B. And we consider a constant C. And we want to show that the limit of the sum, product, scalar product, and the quotient of these two of the terms in the series AN and BN can be derived or can be computed using the limits of the individual sequences. Kaya ang tawag sa kanila algebraic. Kasi yung sequence yung limit ng sum, ng product, ng constant multiple, ng quotient ay kinocompute natin using algebraic operations on the limits of the two sequences. Okay? So let's try to prove some of these para lang ma-refresh yung memory nyo kung paano nga ba ito pinuprove. But again, we will always stick to the definition. But I guess the hardest part in writing proofs in analysis is always, especially the epsilon definition, is the preliminary analysis. So it will be very helpful if you can develop intuition about the problem itself by doing a nice preliminary analysis. And actually, siguro, bulk of the work really lies on the prelim analysis kasi nakita nyo last time nung nag-prove tayo ng limit by definition, almost 70% nasa prelim analysis and 30% is just formalizing the prelim analysis but working backwards. Yun yung gagawin natin dito. So though masa-search nyo sa internet yung mga proof or na-prove nyo na to dati, let's take a review and see paano nga ba or bakit ganon yung idea sa proof. Okay. So let's start with the first statement that the limit of an plus or minus bn as n approaches infinity is equal to a plus or minus b, right? A and b being the limits of the respective series an and bn. Okay, so what do we want to show here? We want to show that for any given epsilon, there exists a capital N. So the goal is, given an epsilon, an arbitrary epsilon, however small it is, we want to find, via the preliminary analysis, a natural number n, usually dependent on epsilon. So posibleng may epsilon kayo makikita dun sa expression for capital N that we will choose, such that for all little n greater than or equal to that choice of capital N that we just declared after the epsilon, the following inequality holds. The absolute value of the terms in the sequence. Here, our sequence comprised of terms that are the sum of the terms in the on the two sequences. So magkakaroon tayo ng an plus or minus bn minus the supposed limit. So we are claiming that the limit is a plus or minus b. So minus natin siya dyan. Siya yung subtrahend. And we want this to be less than epsilon. Okay? So this is our end goal. Makahanap ng capital N na magiging totoo itong inequality na to for any little n greater than our big N. Okay? Now, what do we know? So, pauso ako ng abbreviation, WKT, we know that ano yung mga alam natin from assumption. So because I always find it helpful to list also those things that I know from the assumptions para alam ko ano yung mga tools na pwede kong gamitin. Kumbaga, I am laying all my cards on the table and see how can I manipulate them in order to arrive at the conclusion I wanted. Okay? Now, ano yung alam ko? Alam natin na yung limit ni AN ay equal kay B. So, ibig sabihin, for all epsilon greater than 0, there exists a capital N for the sequence of A's, capital N, such that whenever N is greater than or equal to N sub A, ginawa ko lang N sub A just to denote that this choice of capital N sub A is for the sequence of ANs, okay? Such that the absolute value of AN minus A is less than any epsilon, however small. So basically the idea, I can choose a beginning subscript such that whenever I get past that beginning subscript, the distance between AN and the supposed limit is very, very small. Because remember, epsilon must work for any small value, right? So in essence, kaya kong palapitin si AN kay A o sa halos dulo ng listahan si AN palapit ng palapit kay E o kay palapit ng palapit kay A. Right? Now, similarly, pwede ko rin itong gawin para sa mga BNs. Okay. So, so may mahanap ako na big N sub B such that whenever my subscript is greater than N sub B, yung B sub N minus B ay within epsilon distance. Okay? And then in my prelim analysis, hold on guys. Okay? In the prelim analysis, I now know ito yung gusto ko. Ito yung meron ako right now. Okay? Now, I want to manipulate this para makakuha ko ng something like this, which is less than epsilon. Okay? So maybe I'll go here. Okay, paano ko to masusulat in terms of the things that I know, right? So, papayin ko siya dito. Okay? Tapos na yung we know that. Ito na yung gusto kong mangyari. Gusto ko to ay maging less than epsilon. Gusto ko tong mapaliit. I want this to become very, very small. All right? Now, if I want to make it small, what I can do is to get a number that is larger than this guy and impose that that new number is less than epsilon. And I want that new number to be somewhat related to these two guys that I know are bounded by some epsilon. Okay? So, pwede ko itong isulat na, you can use triangle inequality. So, note AN minus A. So, dinistribute ko lang to. Okay? And then, magkakaroon ako ng plus or minus BN. Di pala. Minus, sulat ko nga muna siya ng buo. A sub n plus or minus B sub n minus A minus plus B sub n. Right? And then I can rearrange the terms para maging at least kamukha na siya ng mga alam kong mga mula dun sa assumption. Right? So I can rearrange the terms inside the absolute value in this way. A sub n minus A. And then I'll have plus or minus B sub n minus plus. Ito mga pinagsusulat ko. Alam niyong pahapon na kasi kung ano-ano na yung mga sinusulat ko. Alright, so sana tama pa rin to so far, right? So nire-arrange ko lang yung terms. And then again, I want to bank on what I already know. Ang alam ko ay isang bound para kay AN minus A at hiwalay na bound para kay B sub n minus B. So, kaya lang dito nasa loob sila ng absolute value. So paano ko sila mapapaghiwalay? So you think of a tool that will allow us to separate sums inside an absolute value. And this should remind you of the triangle inequality. In triangle inequality, pagka meron kang sum sa loob ng absolute value, pwede mo silang i-split into a sum of two absolute values. At yung value na yon ay mas malaki dun sa original sum. So that means I can split the absolute value into two pieces. this way, right? Pero take note of the change of the order relation, less than or equal to na siya dito sa previous statement. Okay? And then I say, a little bit of a trick here, an minus a, kasi yung pangalawa halos hindi pa siya kamukha ng gusto nating makuha. Yung alam natin from the assumption. Alam natin sa assumption, yung absolute value ng bn minus b ay mas maliit sa epsilon. Pero meron pa rito mga plus, minus, minus, plus. Pero tingnan niyo yung mangyayari. Kung siya'y positive, negative yung pangalawa, so makukuha ko yung bn minus b as what we have from the assumption. Pero yung kabilang case, negative bn, ba't lagi ako may bn? So, plus b, right? Ito naman yung second case, pag yung nasa ilalim na signs yung kinuha ko. Pero you notice that here, I can factor out the negative sign out of the absolute value bars. So, absolute value ng negative 1 times b sub n minus b. Absolute value of b sub n is 1. So, it reduces to b sub n minus b, which is the same thing as the first case. So, instead na mamroblema pa ako dun sa plus, minus, minus, plus, equal lang pala sila either case dito sa value na to. And note, I preserve the equality here. Okay? Tapos ngayon, medyo okay na ako kasi alam ko na ito ay mas maliit sa epsilon. Ito ay mas maliit sa epsilon. Right? So, pag pinalitan ko yung mga terms by something larger than them, then the new sum will be larger than the previous sum. Right? Okay. So, ano nga lang yung problema natin dito? Pag inad ko itong dalawa, epsilon to epsilon, tama? Bakit naghanga ako doon? Epsilon plus epsilon to epsilon, alright? So, ano napakita natin ngayon? So, with this choice, we have shown that this guy is less than twice epsilon. Pero sa definition natin, ano yung gusto natin makita? Gusto natin maging less than epsilon siya. Just to make our proof elegant and in the same form as what we have in the definition, gusto kong ma-force yung issue na ito ay maging epsilon. Pero posible nga ba? Well, would you agree na pwede ko itong palitan ng epsilon over 2 at saka ito ay epsilon over 2 rin para yung sum maging epsilon? Of course, yung algebra is true. Tama? Epsilon over 2 plus epsilon over 2 equals epsilon. So we were able to show that this guy is really less than epsilon. End of proof na tayo. Pero pwede ko nga bang gawin? Ang alam ko kasi dun sa statement sa taas or sa assumption, ito ay mas maliit sa epsilon. Ito ay mas maliit sa epsilon. So, pwede ko nga ba talagang palitan ng epsilon over 2 yung bound para sa kanila? Any thoughts on that? Valid ba yung ginawa kong yan? Or gusto ko lang kasing magpasikat na yung sum ay maging epsilon, so pinupwersa ko na maging epsilon over 2 parehas. What do you think? Ito yung amaze na amaze ako dati nung estudyante ako nung undergrad. Amaze na amaze ako na pag yung teacher ko naglagay ng epsilon over 2 dun sa proof niya or naglagay siya ng epsilon over m dun sa proof niya. Na I don't know where kung saan nanggaling, hindi ko alam kung saan nanggaling yung over 2 o kaya yung over m. And I thought hindi ko siya kayang i-anticipate pag ako na yung susulat ng proof ko. Pero sa prelim analysis na to, nakita natin na, nga, kailangan pa epsilon over 2 saka epsilon over 2. Or if you want to be fancier about it, you can say, pwede itong epsilon over 3. Tapos ito ay 2/3 epsilon. Para yung sum pa rin nila ay maging epsilon. But can we really do that? Can we force this to be less than epsilon over 2 and this guy to be also less than epsilon over 2? Ano yung justification? Madali, salita naman kayo guys. Habang iinom ako ng kape. Or masyado na ba kayong pagod to speak and to think today? Come on, guys. Wala naman deductions pagka hindi ganun katama yung sinabi. Bakit ko to pwedeng gawin? Kasi ang usapan dun sa we know that, sinulat ko pa nga eh. Ito ay less than epsilon. Ito ay less than epsilon. Pero ngayon, nakita ko dapat yung sum ay maging equal kay epsilon. So a nice candidate would be to make it less than epsilon over 2 and this guy to be less than epsilon over 2. Pero posible ba yun? Ano yung justification? Why can I do that? Ayaw talaga? Sirit na. So the idea lies in the quantifier in the definition of the limit of a sequence. Remember, these two inequalities are true for any epsilon greater than 0. So if epsilon is greater than 0, then epsilon over 2 must also be greater than 0. So dahil si epsilon over 2 ay greater than 0, I can always find a different natural number n sub a and possibly a different natural number n sub b such that this absolute difference is less than epsilon over 2 tapos ito ay less than epsilon over 2 rin. Kasi nga for all ito, nag-work sila sa kahit ng epsilon. Lagi tayong may nakikitang lower bound dun sa subscript na magiging super malapit na yung terms ng sequence dun sa limit and they would be within that positive number distance. Okay? Or, in layman's term, dahil ang limit ni an ay si a, we can make this very, very small. So if we can make it smaller than epsilon, then I can make it even smaller, say epsilon over 2. Kasi ito rin, si bn, ang limit niya ay b. So ibig sabihin ito, kaya kong paliitin pa kaysa kay epsilon. I can make it smaller than any positive real number. And if I can do it, if I know that it is less than epsilon, I can force that it becomes less than epsilon over 2 as well. And I need to do those to decompose them so that the sum of the bounds should be epsilon as required by the definition. Okay? Does that make sense? So, hindi na ngayon sana malaking misteryo kung bakit dun sa proof may lumalabas na epsilon over 2. So, nakikita nyo talaga siya sa preliminary analysis. Okay? Now, if you want to write the formal proof, okay, you can do it this way. So, you can always, we start by letting epsilon be greater than 0. We pick an arbitrary epsilon. Because again, we want to show that for all epsilon, we can find a capital N. All right? So, given ka daw ng epsilon. Pero if we are given an epsilon greater than 0, then from the assumption, when I say the assumption, I'm referring to the assumption that the two sequences converge to A and B respectively. Then from the assumption, there will exist natural numbers NA and NB such that for all little n greater than or equal to NA and little n greater than or equal to NB, n sub B, the following inequalities hold. So we have absolute value of an minus a less than epsilon over 2 and bn minus b is less than epsilon over 2. Right? Or if you're uncomfortable having epsilon over 2 dito, pwede nyo gawin let epsilon over 2 be greater than 0. So masasatisfy nyo na yung definition, right? Pero understood nyo naman yun. Kung si epsilon ay greater than 0, say epsilon over 2 ay greater than 0, so by definition ng limit ng sequence, may nag-exist the natural numbers NA and NB such that these two inequalities are true. All right? And then ngayon, I will just go back to the prelim analysis and write it backwards. Right? Then, if we look at a sub n plus or minus b sub n minus the supposed limit a plus or minus b. Again, we knew that this is equal to an minus a plus or minus bn minus plus b, right? Nakita na natin to sa prelim analysis. And then I can say this is less than or equal to absolute value of an minus a plus absolute value of bn minus b, as we discussed earlier. And then again, this is less than epsilon over 2 by definition. And then this is less than epsilon over 2 by definition. Or actually, totoo lang pala to for specific little n's. So here I should choose what is that capital N. Then for all little n greater than or equal to big N, which I take to be the maximum of NA and NB, we have the following inequality, right? And then magiging equal na to sa epsilon. So why do you think did I choose capital N to be the maximum between NA and NB? Any idea? Munti ko pa siya makalimutan eh. Pero crucial siya. Kasi hindi naman ito totoo sa lahat ng little n. Totoo lang siya after some threshold or some starting value for the subscript. And here, I chose that starting subscript to be the maximum between n sub a and n sub b. Bakit ko kinuha yung mas malaki sa kanila? Any idea? It could be technical, it could be layman's or intuitive explanation. Bakit? Bakit max, hindi mean? Come on guys, wala talaga. Tahimik nyo ah. So bakit max? Kasi totoo itong first statement starting kay NA hanggang sa dulo or and so on. Yung pangalawang statement, totoo siya kay NB and so on. But I want them to be both true at the same time para makonclude ko tong inequality na to. So magiging totoo sila starting from the bigger value and so on. Doon sila parehas nagiging tama. Starting dun sa mas malaki. Kaya ang pinili ko, maximum ni NA at saka ni NB. So ito na yung capital N na hinihingi ng epsilon definition ng limit ng sequence. Kasi given di ba yung epsilon, kailangan nating hanapan ng capital N such that this guy is less than epsilon. And here we found what that capital N should be. It should be the maximum between NA and NB. Right? Actually, hindi nga lang ito yung possible choice eh. Hindi lang yung maximum. Can you give me another choice for capital N? Ayan. Ano pa yung posibleng choice ko for capital N? Would you agree that N sub A plus N sub B is also a good candidate? Kasi definitely, mas malaki to sa parehas na NA at saka NB. So this could also be your choice for capital N. Okay? But either way, we have found at least one capital N as a response to any epsilon greater than 0, such that this guy is less than epsilon. And so we're done. We have proven that the limit of a sum is the sum of the limits. Okay? Walang sumasagot, so kinakabahan ako. Is everything making sense? Na ayaw nyo lang talagang sumagot. Kinakabahan ako, masyado kayong tahimik. So I hope I'm making sense and not just blabbering gibberish this afternoon. Okay. So mahihain talaga kayo. What's the other statement? The other statement in the theorem is limit of a product, an, bn. As n approaches infinity, ay sabi raw ay limit daw na ay equal sa a times b. So ang limit ng product ay product ng limits. Okay? So again, let's do a PA. So we want to show that for every epsilon greater than 0, there exists a capital N in n such that for all little n greater than or equal to capital N, the following inequality holds. The nth term of your sequence minus the limit must be less than epsilon. Okay. Ito yung gusto nating ipakita. Makahanap ng capital N that will ensure that this inequality is true. Okay? Now, what do we know? Kaparehas lang din nung kanina. Papihin ko na lang siya. Okay. Ito yung alam natin mula sa assumption, alright? Na may nag-exist. So again, my goal is to try to manipulate this, the left-hand side of the inequality, para maging kamukha siya ng mga left-hand sides nitong dalawang inequality that I know can be true for any epsilon greater than 0. So I'll try to manipulate this. Ang problema, an times bn, medyo actually coupled si an at saka si bn. So kailangan ko silang mapaghiwalay. Paano ko sila mapapaghiwalay? Well, a usual trick is to force one to be factored from another. Okay? So gusto ko dito mangyari ay ganito. Si an, bn, minus ab. Masulat ko in another way such that ma-decouple ko yung mga factors. And I can only hope that they be decoupled by adding and subtracting some quantities para magawa ko yung factoring. Alright? So, halimbawa dito, gusto ko mawala si bn, mahiwalay siya kay an. So, para mangyari yon, so an, bn, pwede akong mag-subtract ng something that involves bn. Okay? Pero ano yung gusto kong mangyari? Gusto ko ay magkaroon ng an minus a, right? Yan yung gusto kong ma-achieve para magamit ko yung inequality with a small number. Okay? Gusto kong magka-an minus a. So meron akong an, bn. Magsusubtract ako ng something para pag nag-factor ako ng bn, kasi yun yung goal ko, mawala yung bn, magkaroon ako ng an minus a. So I guess you can see na magsusubtract ako ng bn times a. Para pag finactor ko yung bn, matitira yung an minus a, kamukha na siya ng unang inequality that we know to be true. Okay? Kaya lang, kapag kasya lang yung nilagay ko dyan, hindi na magiging totoo yung equality. So I need to take it back by adding the same quantity, bn times a, and hope that this will not ruin our strategy. Okay? Kopyahin ko lang yung natitirang term. And actually, it turns out to be advantageous because if you look at these two terms, pwede ko ngayong i-factor out si a. Tapos pag finactor out ko si a, magiging bn minus b. Luckily, that matches the second inequality that I want. So kung babasahin niyo yung module o magbabasa kayo ng books, parang out of nowhere, nag-add and subtract ng ganitong bagay. Pero I hope now you see why it is necessary that I add and subtract this two terms or this term para lang ma-achieve yung gusto kong effect of having these two terms on my inequality. Okay? Now, acting on my strategy, i-group ko siya sa dalawa. Doon sa unang group, mapa-factor ko si b sub n. So matitira si an minus a. Plus, doon sa second group, mapa-factor out ko si a. Matitira si bn minus b. And then I can use the triangle inequality again kasi gusto ko itong ma-split into two pieces. And luckily, triangle inequality results to a less than or equal to relation. So this will be absolute value of bn times an minus a plus absolute value of a bn minus b. Alright? Tapos, ilabas ko lang yung b sub n inside absolute value, an minus a plus this guy. Tapos gusto ko tong result ay maging less than epsilon. Pero pwede ko rin pala itong gawin. An minus a plus, pagbaligtarin ko lang yung order sa kabila. So that is the same, tama ba? Oh, hindi ko na pala siya kailangan baliktarin. Okay na yung form nito. Oops. Okay na yung form nito. So we want this to be ultimately less than epsilon. Pero alam ko to, kaya ko itong mapaliit because I can make it less than epsilon or any positive real number. Okay? Pero ang problema, kung papalitan ko lang to ng epsilon, magkakaroon pa kasi yan ng absolute value of a dito sa baba. Right? Na factor. Eh gusto ko lang magkaroon siya ng epsilon. So ano kayang pwede kong gawin? Instead na i-force na si bn minus b ay maging mas maliit kay epsilon, why not change my capital N sub b so that this guy will be smaller than this guy? Right? Para maka-cancel yung absolute value of a, maka-cancel yung absolute value of a, epsilon, pero gayahin ko yung strategy ko kanina, gawin ko tong 2. Para itong term na to ay maging less than epsilon over 2. Okay? Now, how about the other? This is fine because absolute value of A is a constant. Kasi siya yung limit ng sequence. Constant siya. Problema ko ay dito sa kabila. Ganun din sana yung gagawin kong strategy. Papalitan ko to ng less than. Tapos ito, papalitan ko to. So a factor of epsilon, possibly over some constant. Okay? Pero ang problema ko, anong pwede kong gawin kay Bn? Hindi ko pwedeng ilagay dito si Bn. Kasi si Bn ay hindi constant. So, hindi ko sure kung anong value to. Constant lang dapat yung bounds ko dito sa side na to. Hindi na siya nag-involve ng little n. Okay? So, hindi pwedeng ma-bound siya by absolute value of Bn. So, ano ang pwede kong gawin kaya? Any suggestion? Okay, remember what do we know? We know that the Bn's converge to B. And remember our theorem earlier. If you have a convergent series, if you have a convergent sequence, then that sequence is bounded. Correct? So since, pwede kong lagay dito, since Bn converges to B, then Bn is bounded. Or the sequence Bn is bounded. So kung bounded siya, there exists a capital M, a real number capital M, such that the absolute value of Bn is less than capital M for all n. So makakakita ako ng number na mas malaki sa lahat ng posibleng Bn's. And so I can put that big number here and maintain the inequality. Kasi nga, papalitan ko to ng something na mas malaki. Huwag ko lang bawasan yung value ng ibang expressions dito sa term na to or sa line na to, then I will get something larger. Okay? Now, what can we do about this guy? We know this is less than epsilon, pero kailangan ko to mag-add up sa epsilon. So, ibig sabihin, dapat i-divide ko siya by 2m. M is a constant, that's fine. So this is still greater than 0, so I can always find a capital N sub a such that this guy is less than epsilon over 2m. And I wanted a sub n minus a to be within epsilon over 2m units away from each other so that maka-cancel si m, maka-cancel si m. Ito ay magiging equal sa epsilon over 2 plus cancel din to, epsilon over 2 equal kay epsilon. Okay? So ultimately, in the prelim analysis, we have found a way so that this guy will be forced to be less than epsilon. And that is by relying on nice choice of the capital N sub A and capital N sub B that will allow us to bound this difference by epsilon over 2m and this difference by epsilon over 2 times absolute value of A. So pipiliin nyo lang. So ibig sabihin may makikita ka na dun sa proof. Hindi ko na isusulat ng detalyado, pero I hope you can write it there. So given an epsilon greater than 0, there exists an NA and NB. in n such that a sub n minus a is less than epsilon over 2m and bn minus b is less than epsilon over 2 absolute value of a, okay, whenever n is greater than or equal to na and little n is greater than or equal to nb, right? And then, ulitin nyo lang yung prelim analysis. Sulat nyo lang siya dito. But you will arrive at the conclusion that this guy is less than epsilon. Pero totoo lang siya kailan? For all n greater than or equal to capital N. So what is our choice for capital N? Again, gusto kong pilihan si capital N para parehas na to ay totoo. Kasi kung parehas ito ay totoo, ibig sabihin mag-hold itong dalawang inequalities na yan. Right? So again, I will choose capital N to be the maximum between NA and NB. Or you can say I will choose capital N to be a number greater than these two guys. Or capital N to be NA plus NB or 2NA plus 3NB, anything larger than both NA and NB. And then I guess you can supply the rest of the proof. Okay? Is that good? Okay, I hope it is. Okay. So, andito na yung proof. So, I would like you to try proving parts C and D. Yung part C, straightforward siya, pero yung part D ay komplikado yung trait na gagamitin. Or, di ba, kailangan mo dyan ng Bn over An minus B over A. Tapos kailangan mo siyang masulat na merong Na minus A at saka Bn minus B. Medyo tricky, mas komplikado yung i-add and i-subtract nyo. Pero give it a shot. If you get stuck, nandiyan naman si internet para bigyan kayo ng idea ano kaya dapat yung expansion. Okay? All right. No questions so far? I hope I'm making a little sense at least. Okay. Let's look at the order limit theorems. So kanina algebraic. Ngayon naman tingnan natin yung mga theorems about limits involving order relations. So, okay. So sabi dito, so we suppose that the limit of an is equal to a and limit of bn is equal to b. Statement number 1. Kapag ka lahat ng terms dun sa sequence, actually hindi natin to kailangan pala. Hindi natin kailangan yung pangalawa kasi wala namang bn's involved dun sa statement. So, sabi ng statement number 1, kapag ka lahat ng terms sa sequence ay non-negative, then yung limit dapat ay non-negative din. So kung lahat ay non-negative, imposible na yung limit niya ay maging negative. Tapos, kailangan pala yung bn, sorry. I spoke too soon. Statement B, kapag ka lahat ng terms, kapag ka yung mga an's ay mas maliit sa bn's for every n. So ibig sabihin yung a1 mas maliit sa less than or equal sa b1, yung a2 less than or equal sa b2, and so on. And this will happen for every natural number n. Then sabi niya, yung limit ng an dapat mas maliit sa limit ng bn. Kasi nga, term by term, mas maliit yung mga an's kaysa dun sa mga bn's. So it is impossible for the limit a to be greater than the limit b. Okay? And then third state, if you have a real number c na mas malaki sa lahat ng an's, then dapat yung limit ni an hindi mas malaki kaysa kay c. Or in other words, this three theorems combined imply that the ordering is preserved, right? Whenever your sequences satisfy certain order relations, okay? So let's try to prove it. Naglagay ba ako ng space? Yeah, I think I wrote some space here. First statement, let's prove that if an is non-negative for all n, then a is greater than or equal to 0. And let's do this via contradiction. So proof. Suppose for sake of contradiction that a is less than 0. If a is less than 0, then a over 2, or actually hindi ko nga kailangan ng a over 2 eh. So gawin ko ng then negative a is positive. Okay? Nothing fancy about that. Then dahil si an nagko-converge sa a, right? Then there exists a capital N such that for all little n greater than or equal to capital N, ang absolute value ng an minus a ay less than negative a. Agree? Kasi ang assumption natin, si a ay negative. So si negative a dapat positive. Dahil si negative ay positive, pwede siyang maging epsilon. So therefore, dun sa definition ng limit, there will exist a capital N such that after that capital N, the difference between a little n minus a is less than that choice of epsilon. In particular, we chose it to be negative a, right? Pero anong implication nito? Well, from your algebra classes, pwede kong itong i-expand as a triple inequality, right? Or a continued inequality. So ito ay a less than an minus a less than negative a. And then I can add a to all sides of the inequality by the addition property. What will I have? 2a less than an less than 0. And here I say there's a contradiction. Why is there a contradiction there? Oh, guys, so wala. Walang gusto magtanong? Magsagot? Ano yung contradiction? Bakit sabi ko contradiction yan? Na ang 2a less than an less than 0. Ayaw nyo pa rin? Okay, the contradiction, there's a contradiction there because from assumption, the ANs are all greater than or equal to 0. Lahat ng ANs ay non-negative. Pero here we are saying that after capital N, lahat ng mga ANs daw ay magiging less than 0. Pero sabi sa assumption, lahat ng AN ay greater than or equal to 0. And yet here we are saying that there exists a starting point wherein past that point, a sub n becomes negative. So that's a big contradiction, right? Because a number cannot be greater than or equal to 0 and less than 0 at the same time. Okay. So therefore, since we have a contradiction, we must accept the negation of our supposition. So therefore, a cannot be less than 0. That means a is greater than 0 and the proof. Okay. Now, what's the other statement? Next statement is if an is less than or equal to bn, then a is less than or equal to b. Okay. The proof here will utilize the previous result. Kasi na-prove na natin yung result kanina. Pwede ko siyang gamitin dito, right? So note that b sub n minus a sub n is greater than or equal to 0 for all n in n. Kasi ito ay totoo daw for all n in n. So mag-subtract lang ako ng an from both sides, I'll get a positive sequence. And then by previous theorem, which is one of those algebraic theorems, bn minus an will converge to what? This will converge to b minus a. Okay. So by case 1 or by by the last result that we have just proven. Dahil si Bn minus An ay non-negative sa lahat ng n, tapos si Bn minus An nagko-converge sa Ba, so dapat yung limit non-negative din, right? Yun yung pinrove natin, yung kakaprove pa lang natin. So this means B minus A must be greater than or equal to 0, or equivalently, A is less than or equal to B as claimed. End of proof. Okay? Is that fine? Guys, mag-react naman kayo. Para alam ko nandyan pa kayo. Gusto ko sanang magtawag randomly. Kaya lang baka wala nang umattend sa inyo next meeting. So, yeah. At least ngayon, I get to at least see your DPs in Teams. But anyway. Okay, last result. If A sub n is bounded by C for all n, then A is less than or equal to C. Okay. Anyone? Ano kaya yung posibleng proof approach here? Clue. Gagamitin ko rin yung previous result. Ano ba yung previous result natin? Kapag meron akong convergent sequence kay B na mas malaki sa lahat ng ANs, ibig sabihin yung limit ni limit ng mga ANs ay mas maliit sa limit ng mga BNs. Ang alam ko sa assumption ngayon, lahat ng AN ay mas maliit kay C. So paano ko mapapakita na si A ay mas maliit kaysa kay C? Okay, so to take advantage of the previous result, here I can say, I'll define Bn to be equal to C for all n in n. Magko-construct ako ng bagong sequence ng mga Bn's. Pero yung mga Bn's, lahat sila ay equal kay C. Then I hope you will agree that Bn is convergent and this converges to C, right? So here we have seen that An is less than or equal to Bn by the assumption. Kasi yung mga Bn's, lahat sila ay equal kay C. Then by the last result, yung huli nating pinrove, ibig sabihin si A na limit ng mga ANs ay dapat less than or equal to sa limit ng mga BNs. Pero ang limit ng BN ay si C lamang. And end of proof. Okay? So I hope that makes sense. Or info overload na ba? Hindi pa naman. Kasi super tahimik nyo eh. Okay, so I hope you're still there. Okay, so here are some exercises you can try later. Siguro next time, pag medyo gusto niyo na magsalita, pwede tayo magsagot ng ilang exercises if you want. Pero dahil walang gustong magsalita, so I'll go to Theorem 2.5 and probably end here. Tingnan ko lang yung mga susunod. Let's see. Yeah. I'll probably stop here at the squeeze theorem. Okay. The squeeze theorem, some books call this the sandwich theorem. Yung iba ang tawag ay pinching theorem. Medyo surprised ako na when I taught in the States, hindi nila alam, hindi nila tinatawag na squeeze theorem to. Tawag nila ay pinching theorem o kaya sandwich theorem. I don't know if it's just local to us o yung version ng mga books na nakukuha natin, ang tawag sa kanya is squeeze theorem. Pero other terms for it are the sandwich theorem and pinching theorem. Ano lang sinasabi niya? Kapag meron kang sequence, tatlong sequences, na lahat sila na sina-sandwich ni AN at saka ni BN si CN. So kung ipa-plot niyo yung, pala pwedeng i-plot kasi sequence lang to, no? So kung sa bawat N, yung CN ay nasa pagitan ni AN at saka ni BN. And it so happened that the limit of AN and the limit of BN are both equal to L. Excuse me. Okay, I'm back. So, ang limit ni AN ay L, ang limit din ni BN ay L. Pero lahat ng terms ni AN at saka ni BN ay nagsasandwich kay CN. Nasa pagitan lagi si CN. And that happens for every N. Tapos parehas yung limit ng dalawang tinapay dun sa sandwich. Then yung palaman na CN, dapat nagko-converge din siya kay L. So the strategy here is if you can find two sequences bounding CN, okay? Two sequences bounding CN, and those two sequences converge to the same value, then the filling, si CN, dapat mag-converge din kay L. Okay? And I guess you have used this a lot of times before in Math 36 and possibly in 38. So, pero balikan natin. Ano yung proof ng squeeze theorem? Kalimutan ko na yung proof ng squeeze theorem sa calculus, pero parang gumamit yata doon ng I forgot what was specifically used there. I forgot it from yeah. Pero mas simple yung proof ng sandwich theorem sa sequences. So let's see. So ang gusto nating pakita is ito yung we want to show for all epsilon greater than 0, there exists a capital N in N such that whenever little n is greater than capital N, then Cn minus L is less than epsilon. Okay? So yan yung gusto nating ipakita. Now, I'll do this. So I'll consider an arbitrary epsilon greater than 0. Okay? Then there exists an NA and NB such that for all n, which is greater than or equal to the maximum ng NA at saka NB, sama ko na sila dito kasi gusto kong sabay mangyari itong susunod na inequality. So, ang capital N ko dito sa definition na to ay, dito sa proof na to ay maximum ng N sub A at N sub B. Sa lahat ng little n na mas malaki sa N sub A and N sub B, sabay na nangyayari itong dalawang inequalities na to. A sub N minus A is less than L, and B sub N minus B less than L, right? And this will be true for all little n's na mas malaki sa NA and NB. Yung NA at NB, siya yung kailangan ko. Anong sinulat ko? Mali. Kailangan na daw mag-dinner. So, kaya mali-mali na. So, minus L pala, less than epsilon. Minus L epsilon. Okay? Alright, so sabay sila nangyayari kasi si little n, pinili ko na to be larger than the supposed choice for A, so that this inequality is 2. And then the choice N sub B for the minimum subscript, so that this inequality is true. Pinagsabay ko na sila. Gusto ko sabay silang mangyari. Okay? And then now, what do we know? Well, I know that, well, from here, I'll know that negative epsilon is less than an minus L less than epsilon, and the negative epsilon is less than bn minus L less than epsilon. Definition ng absolute ng inequality involving absolute values. All right? Pero ano yung assumption natin? Assumption natin si an ay less than or equal to c. So probably I can play with these inequalities and look for a lower bound for a sub n. Okay? So in order to achieve that, I'll just need to add L to all sides of this inequality. So I'll get L plus epsilon, L minus epsilon less than a sub n less than L plus epsilon. Okay? And then similarly here, I can add L to all sides. So I'll have L minus epsilon less than Bn less than L plus epsilon. Okay? And then I know that Cn from assumption is less than or is greater than or equal to An, but less than or equal to Bn from assumption. Pero from the previous line, we have seen that An is strictly less than L minus epsilon. And here, Bn is less than L plus epsilon for all epsilon. Okay? Or actually, I can simplify it further and say, oh, ang kailangan ko lang naman ay Cn less than L plus epsilon. Parang may problema yata yung inequalities kung kinuha. Oh, probably I can do it this way. I can subtract. Oh, so I have L minus epsilon less than or equal. Less than Cn. So kinuha ko to less than kay Cn. Tapos ito ay less than L plus epsilon. And then I can subtract L from all sides of the inequality. So I'll get negative epsilon less than Cn minus L less than epsilon, right? And by definition of a continued inequality, this is Cn minus L less than epsilon as desired, right? So end of proof. Because again, here, we were given an arbitrary epsilon greater than 0, and we have shown that we can find a lower threshold for the subscripts, namely, that is the maximum between NA and NB, such that this inequality is true. So therefore, you can finish the proof by saying Cn converges to L. End of proof. Okay, so that's one of the proofs of the squeeze theorem for sequences. So I'll probably stop here. So any questions? So probably let's start next week's meeting with example 2.3. And then we'll go to subsequences. And then konti na lang yung matitira sa section na to. Okay, any questions? Any reaction? Or gusto ko lang marinig yung boses nyo. So parang 1 hour and 20 minutes akong nag-monologue dito. No questions?
Wala po, sir.
Okay, so but I hope you got something from today, kahit tahimik kayo. So, okay. So I'll end with some reminders. Again, homework number 3 is due on Monday right before midnight. Don't forget to answer the bonus question that is again plus 20% ulit dun sa over. Oh, by the way, dun nga pala sa Canvas, makikita nyo yung standing nyo. Kung mapapansin nyo, over 100% pa yung karamihan. Or I guess if not all of you are still over 100%. Kino-compute lang ni Canvas yung relative standing dependent dun sa mga na-checkan na. Alright? So, halimbawa, nagpasa na kayo ng homework 1 at saka homework 2. Pareha silang over 5. Tapos halimbawa, naka-4 kayo dito, naka-5 kayo. Tapos meron tayong homework 0. Yung homework 0, ginawa ko lang siyang bonus, wala siyang denominator. So if you answered the 0th homework, meron kayong additional 5 points. So ang total ay 14. So kukompute nito ni Canvas na 14 over 10. So meron kayong 140%. So kaya wag niyong kalimutang sagutan yung mga bonus kasi pangdagdag din siya. Alright? Baka sa end ng SEM, konti na lang yung kailangan nyo para mag-jump dun sa susunod na grade. So take advantage ng mga bonus questions. I included the bonus question for homework number 3. So kindly take note of that. And then on kailan nga ba? On Friday next week, I'll give you problem set number 1. It will be live on Canvas 8 a.m. Tapos I think you have until kailan nga yung sinabi natin? Wednesday nga ba next week to submit problem set 1. Though pwede nyo nang isubmit kahit isang item pa lang yung natatapos nyo. Mag-create ako ng individual submission bins kay Canvas per problem. Para pagtapos na kayo sa problem 3, kahit hindi pa kayo tapos dun sa ibang mga problems, pwede nyo nang i-upload si problem 3. Pwede ko na rin siyang checkan. Okay? So, yeah. So if there are no other concerns, then thank you guys for coming today. Have a good dinner, and then let's see each other again next week. Oh, enjoy your weekend. Bye, guys.
Thank you po, sir.
Mm-hmm.
Thank you po, sir.
Yan, finally, narinig ko rin yung mga bosses nyo. Ayaw nyo ng bonus points?